Hey everybody, this is Mr. Tranetsky, and this is Unit 2.1, Lesson 1, Intro to Triangles. So this is a pretty short lesson. Our first task is we are going to classify triangles. Now, triangles are classified two ways, by sides and by angles. If we're classifying by sides, there's three classifications. There's equilateral, isosceles, and scalene. An equilateral triangle means that all three sides are equal or congruent. An isosceles triangle means that two sides are congruent. Now, a little bonus for isosceles and equilateral triangles. If I know that in a equilateral triangle all three sides are equal, I also know that all three angles are equal. And in an isosceles triangle, I know that just these two bottom base angles are equal. Let me draw that. So these two bottom congruent angles are base angles. And those are equal. A scalene triangle means we have no equal sides. All three sides are different. So this is the classification of triangles by sides. We also classify triangles by their angles. An acute triangle has all three angles are acute. Something, it's almost equilateral, but pretty close. So all the angles are acute. So if I had something like 53, 60, and 67, that would be all three angles are acute, so we'd have an acute triangle. Equal angular, all three angles are equal. However, we have another name for that, because if all three of our angles are equal, all three of our sides are equal, and we actually just know this as an equilateral. By the way, if all three angles are equal in a triangle, which we'll find out later, there's 180 degrees in all three angles added together, so that means that each of these angles, switch colors here, that's going to be each of these angles is 60 degrees. An obtuse triangle has one obtuse angle. One obtuse angle. You can't have more than one because obtuse means more than 90 degrees. So if you had more than one, you'd have more degrees in just those two angles. need to have available for a whole triangle. So, and then right triangle, we're pretty familiar with what a right triangle is. We've been working with those a lot. One right angle. And these are the triangles we've been using Pythagorean theorem on. There's two properties we're going to talk about. Today we're going to talk about the triangle sum theorem, which I've alluded to a little bit, which simply states that all three angles in a triangle add to 180 degrees. And there's a link here on your notes. You can click on that to go to a GeoGebra. And yep, triangle sum here. So here I have a triangle, and what I've done is I've copied all three angles, almost like I cut them out and placed them right next to each other. And what's really cool is, and you can play with this too on the GeoGebra link, no matter what shape my triangle is, you can see that all three angles add together to give us 180 degrees. It's almost, yeah, it's impossible. I can't, no matter which way I do, I can make some smaller, some bigger, but they're always going to add up to be 180. So we got some sample problems here with that. So in this one, I've got a 52-degree angle and a 43-degree angle, and we're asked to find this third angle. Well, one way I can go about that is I can add my 52 plus 43, and that's going to give me 95. And if I subtract 180, or 95 from 180, I'm going to get 85. So that's going to be my answer for number 7 there. Number 8, switch colors here. We don't have any numbers here, but I do know that all three of these values, all three of these angles are going to add up to be 180, so I can add x plus 2x plus 3x equals 180. From here I can collect my like terms. I got 3x plus another 3x, so it's going to be 6x equal to 180. And if I divide by 6, I would get x equal to 30. And I could plug that in just to make sure. So if I plug it in here, that would give me 30. 2 times 30 gives me 60. And 3 times 30 gives me 90. 30 plus 60 is 90. 90 plus 90 gives me 180. So it checks out. Our last problem here. Again, I don't have any numbers, but I can set up an equation. I do know that this is 90. So I can say that 90 plus x plus 5 plus 2x minus 2 equals 180. I can collect my like terms, so I've got an x and a 2x, which gives me 3x. 90 plus 5 is 95, minus 2 gives me, gives me 93, which equals 180. I can subtract 93 from both sides. And so I've got 3x equal to 87. Divide by 3. And use my calculator here. 87 divided by 3 equals 29. And that's my answer there. Again, I could plug this in X plus, or 29 plus 5 would be 34. 2 times 29, that would be 58. Minus 2 would give me 56. 56 plus 34 is 90. Plus another 90 gives me 180, so it checks out. Okay. Our last theorem we're going to learn about triangles today is the triangle inequality theorem. And once again, there's a GeoGebra that we can click on. So, the question is here, I've got a length of 10 units, and I've got some other lengths here that I can kind of play around with and see, like, how can I build a triangle? My goal is to connect the C1 and C2 to make a triangle. So right now, as is, I can't quite build a triangle. They're not connecting. They're too short, in other words. So, what if I make, right now this is a 5 and a 4, so these don't quite make. Well, let's make them both 5, maybe. Maybe I can reach in. It almost looks like they will. 5 and 5, so total length of 10. Doesn't, well, even though it looks like it, they're not actually going to line up. If I zoom in, see if I keep zooming in, they're not going to line up until they're laying right on top of each other. In which case we don't have a triangle, we just have a bunch of segments laying down on top of each other. So the only way this is going to work is I've got to make one of these even bigger. So I've got to make either this one bigger, in which case we can actually line these up, and you can actually see where they'll cross, these arcs. They'll cross where we can actually line these up, so they will make a triangle. Or I could have made the green one longer. So now it's got 5 and 4. Well, 6 is still not going to make it. You can see how it's just going to intersect here. It's 4. If they're the same length together as the third length, they're not going to work. But if I can make the two of them longer in length, we can see that, yes, in fact, we can make a triangle. So you can see that our rule really says in the triangle inequality theorem that the two smaller sides must add up to equal, must be add up to be greater than the largest side. Or mathematically saying the smaller sides small side plus small side going to have to be greater than the largest side. So we got some possibilities here. We're going to see if we can make a triangle. So I've got 1, 2, and 5. Well, 1 and 2 add together makes 3, which is not greater than 5, so that's going to be a no. 1, 2, and 3. 1 and 2 add up to 3, which equals 3, but again, that's still a no. Those are going to fold up and make a perfect segment, but not a triangle. How about 2, 3, and 4? Well, 2 plus 3 is 5, which is going to be greater than 4. So yes, that one can make a triangle. How about down here, 1, 3, and 7? Well, 1 plus 3 is 4, which is not greater than 7, so that is a no. 5, 6, and 7. 5 plus 6 is 11. 11 is bigger than 7, so that's a yes. 20, 30, and 40. 20 plus 30 is 50, which is going to be greater than 40, so that works. Number 7, I have to be careful with this one. They didn't order them, all the previous ones were listed in lowest to highest, so I have to be careful. Two smaller sides are 20 and 30, so 20 plus 30 is equal to 50, which is not greater than 70, so that is not a possibility. Okay, and that is the end of this lesson.